Alright, welcome to Lesson 5 of the Bootstrap course on Native SDK. At this point, you should have a pretty decent grasp of the most essential aspects of Native SDK. And that means we're pretty close to achieving what we set out to do with a Bootstrap course. So, right now, what we're going to do is we're going to tie together all the things we've discussed so far in a more elaborate use case, namely cross-chart filtering. So this will serve two functions. The first is to cement everything you've learned so far by showing how all those details work out in a more complicated scenario, and something that's realistically closer to some of the real-world setups you might encounter if you're doing anything non-trivial. The second function is, well, it's just the fact that cross-chart filtering is a relatively common use case, and it's also somewhat non-trivial to set up. So there's a good amount of value in learning how that works, because if you use Native SDK for any non-trivial length of time, there's a decent chance you'll want to do something like this at some point or another. The way this will work is I'll first give a high-level overview of how cross-chart filtering works, both so you can understand how the big picture fits together, and also so you can see how some of the details might be different in your own use cases. Then I'll show you an example of how you might set up cross-chart filtering yourself, step by step. And that will be done in two parts. The first part, what we'll cover in this video, is how do you just set up the prerequisites for cross-chart filtering? Because the bare minimum prerequisite to have cross-chart filtering at all is to have more than one chart and to have those charts share a common data source. And that's not something we've discussed so far in these lessons. So I'll show you how you can set that up, both for the purpose of example and also because it can be different in different use cases, and that might give you an idea of what you might need to do in your use case to make it work for you, and so forth and so on. And then in the next video and the next part, we're going to focus on step-by-step the core aspect of cross-chart filtering. How does the core logic of the filtering work? How do the charts interact with each other? So forth and so on. But all that comes after this video, where we're covering the high-level picture of what goes on, and how do you set up the prerequisites of a data source shared between more than one chart, which is something any case of cross-chart filtering needs. That's a lot to cover, so let's get straight into it. So first of all, let's take the view from 10,000 feet of what exactly is going on when you have cross-chart filtering. So there's two main components going on with a cross-chart filtering system. There's the data source itself, which of course supplies all the data that's going to all the charts that are cross-filtering each other. There's the charts, as you might notice. And the cross-chart filtering system sort of sits in between these things. It determines which chart sees what part of the data based on whatever has happened in the charts, whatever user interactions have occurred. And this is, of course, a very high-level view that doesn't tell you too much, but it does tell you a few important things. First of all, this isn't exactly part of the chart, and it isn't exactly part of the data. Cross-chart filtering is its own system that sort of stands in between these two things, and it acts like the ultimate gatekeeper deciding what one aspect does or doesn't see of the other. So that's the first thing I want you to get out of this illustration. The second thing I want you to get out of this is, where is the cross-chart filtering system located? Because of course your charts, those all happen on the client side, they're in the browser, right? And then you have your data source, which might be local, if it's a local file, for example, but if it's somewhere in a database, especially a big database, this could easily be in a server, or at least not somewhere that's nice and convenient in the same logical space as the charts. So this raises the question, if the cross-chart filtering system isn't necessarily part of the data, and it isn't necessarily part of the chart, where is it? Is this going to be in the browser along with the charts? Is this going to be wherever your data source is, possibly on the server if that's where you're storing the data? And I bring this up because this is really a matter of use case. We have done it both ways in different ways we set up cross-chart filtering. We have sometimes had a server which manages a database with all the data source, and all the cross-chart filtering logic occurs there. So at that point, the client side, the charts, they just say, hey, we've set this event, it'll send it to the server, and then that will create new data for all the charts, and everything's managed there. The client side doesn't need to worry about it. We've also done it the other way around, where you have the data is on the server, and the cross-chart filtering system is just getting and fetching whatever data, and any filtering in the charts is all done with the client side. The server doesn't know anything about it. So this is really a matter of use case. It's a matter of what works best with your requirements, with the technology you have available to you, with whether is the server going to be overloaded by this, or is the client going to be overloaded by this, or anything else. So that's something you should think about if you're going to implement this in your own case. Where do you want this system to occur? And you can even, in fact, do sort of a split system where you do part of it server-side, part of it client-side. So, it's a bit awkward. It's a bit of a no man's land kind of system that can go either way. So that's just something I want you to think about. In this example, we're going to be doing everything on the client side. That might not be ideal if you have, for example, a very big data set, because the filtering system needs access to all the data it's filtering. So if you have to access a lot of data and you're filtering, you might want to err on the side of server side. But here, just for sake of example, we're going to keep things simple, do everything client side. So I just want to point that out right from the get-go. So now that we've talked about where this cross-chart filtering logic will be, and how it's not necessarily part of the data source or part of the charts, I'd like to talk a little bit about how that logic works from a high level. And this is really all that goes into it. There's not really much more to it. So the way I would read this is I would start from the filter conditions. So this comes from interaction with the chart. You select something, you view a certain range, and that creates a filter condition saying, hey, we only want the part of the data that's in this selection or in this range. And all the charts change the filter conditions. So this is something, all the different actions between all the different charts determine the full set of filter conditions that the cross-chart filtering performs. Then, once it knows, okay, we want to filter this specific range of data based on these two criteria in these two different charts, then it performs the filtering. It says, okay, we look at the data source, if it doesn't have it already, and I filter out all the data that doesn't meet the filtering conditions. And one thing that's very important, it doesn't generate just one data set. It generates a different data set for each chart. And the reason for that is because, let's say, for sake of example, one of our charts is a facet chart. And let's say, just for sake of example, that we select one of the items in the facet chart. And that's the filter condition that we change. So it sends something to the cross-chart filtering system that says, hey, we have a new filter condition. We only want data points that are in this Chrome zone. And then it performs filtering. It creates the new data. And here's the thing. What if it applies that filtering to the facet chart data? Then I would lose access to all these other items. I would only see Chrome even in the facet chart. And that's not right. I still want all of the facet chart data available so I could maybe select Safari or Firefox, for example, and continue changing the filtering. I don't want to self-filter, right? And that's why it's important to be able to generate different data sets with cross-chart filtering, because not all of the filter conditions are going to apply to every data set for every chart, so it needs to be selective in how it generates all that. And that's really the main nuance in the cross-chart filtering system. So really, at the high level, that's all there is to cross-chart filtering. It's the charts, the data source, and the system of filter conditions, filtering, and generating different data sets. So just keep this big picture in mind as we're doing it. Because if you want to set up cross-chart filtering for a different sort of use case than the one we're doing, then this is the big idea you need to keep in mind. And as long as you stick to something like this, you should be able to get it set up without too much difficulty. So with that, I think we are okay to go ahead and start building our example of cross-chart filtering. So enough high-level picture, let's get in, let's see an example of how this might work in practice. All right, so here we are, ready to begin the example. The starting point here should be relatively familiar to what we've done so far. This is just the same basic HTML file we've done with all the examples so far. And it has the ZoomCharts latest script. It has 2 divs that are going to contain our charts. And we have our JavaScript, which is mostly empty except for this raw data variable I've gone ahead and created. So this is what's going to simulate our data source. And here I just have an array that, as you might tell from the comment, this is sort of imagining what it might look like after you've parsed a CSV file. So in this case, I'm just having a date for all these different data points. They're just completely made up. You can use any different dates you like. I have a type, again, completely made up. I've just had A, B, and C to various random data points. And value, which again, this is all made up. Just put random values to all the different data points. And that's it. This is just an example so that we can get going. You're welcome to type this out if you like. You can get something similar. But yeah, this is the basic base file that we're going to be starting from. So going by our high-level diagram, we already have our data source. It's this. And the next thing that we need is we need our charts. So that's what we're going to go ahead and create next. So I'm going to just minimize that. And I'm going to do something slightly different than what we've done before. Rather than creating a variable for every individual chart, I'm going to put them in an array. So I'm going to have a charts array. And then I'm just going to add the charts to the array. So chart.push, and we're going to create our charts like that. So the first thing I want is I'm going to use a time chart for sake of example, as you might imagine, because we have the date. So that's going to be the first chart we have. And I'll add the settings in a moment. And the other chart we're going to have is I'm going to have a pie chart. So for our example, these are the 2 charts we're going to have that are cross-chart filtering each other. And we can go ahead and add the settings. So the big thing container, chart 1, and pie chart is going to go in container chart 2. And this is not going to do much, but we can go ahead and refresh, and we can see 2 things actually show up. So we do actually have charts now. So the next thing that we want to do is we want to display our data in our 2 charts. But there's a wrinkle here. The raw data is not in the ZoomCharts format. And this is a very common scenario in the real world. You'll have your data, and it just doesn't come perfectly formatted out of the box, so you'll have to do some basic data conversion. So that's one of the things I wanted to illustrate in our comprehensive use case. And in this case, it's not that complicated, but I just wanted to give you an idea of how it might be done. So for our raw data that's roughly CSV format, well, parsed CSV that is, the 2 big things we want is we want the data values, and we want to separate that from the names of the different columns. So I'm going to do that by creating what I will call raw data values, and this is just going to be the raw data, and I'm going to filter out the first column. So that's exactly what I did. I'm taking the raw data, we're filtering, and as long as the index is not 0, that is, it's not the header column, it's fine. It's still part of the data set. So those are our raw data values. The other thing that we want is we want to be able to index these different data columns by name. Because right now, if I wanted to access, say, the type, I would have to say, oh, I want raw data values sub whatever, and I would have to use 1 specifically in order to get the type, right? Because I get the index of whatever, and then index 1 is the type. That's not ideal. Ideally, it would work something like this. Obviously, this is not valid, but we want to be able to specify by name so that we don't have to memorize, oh, it's column 1, and if the data columns get rearranged later for some reason, which they often do, these things don't break, and so forth and so on. So that's the ideal. That's what we're trying to get here. And the way we do that is, first of all, we're just going to create a data indices object. And this is just going to keep track of the mapping between name and what column index it is. And this is very simple to set up. Just going to do a for loop. So I is 0, I is less than raw data sub 0 dot length. And of course, we're looking at the length of raw data sub 0 because item 0 is the header. That's the one for all the names. So we're going to go through the header, go through all these different names, and what we want to do is say data indices sub, and I'm going to use raw data sub 0 sub I, and that's what we want to index by. So basically, date, for example, or type, or whatever, that's what's going into data indices. And we're going to set that equal to I, equal to the index. So now we can do something like raw data values sub I sub, and then we can say data indices value, and this will get me the value. I can even do something like this. So console.log this, and I should basically be able to get some information here, assuming things don't go nuts. There you go. So it's giving me 87, which if you look, data values starts here because we're filtering out the header. So this will be 0 in data values, then 1, 2, 3. And what's in the value column? 87. So our system of indexing data is working exactly as intended. And we can go ahead and get rid of this now. And at this point, that's really all the infrastructure we need in order to be able to take this parsed CSV data format and load it in ZoomCharts using a data function. So let's go ahead and do that. I'm going to create a data settings, and we're going to have a data function, of course. And this is going to work much like we showed earlier in the lessons, where you have the from and to that ZoomCharts gives us. It also gives us a time step, and it gives us a success and fail function that we can call depending on what happens with our data loading. So I'm just going to immediately say success. We immediately succeed. And we're just going to pass in the values. Now, how do we get the values? So our values come from the raw data values, and we're going to have to do a mapping because this isn't quite ZoomCharts format yet. The format that time chart wants is something like an array of timestamp and value, and something like this. So we're going to have to convert it in order to get it like that. So the way this works, I'm going to actually just say map vals. So that's the variable name that I'm mapping from. And vals will be one of these from our data. And what we want is something very much like we just did with the console.log. So we want vals, and we're going to map that to this new ZoomCharts array. The first thing we want is the timestamp, so vals, and we want the index. So we're going to use data indices, and we want the date. And there we go. That is how the first of our vals work. And then we want another thing here. This is going to be the value. And using our named index, we can just say value. And there you go. And just like that, they should, actually I don't need to have that on a new line if I don't want. Not that it really matters too much either way here. I'll do it like this since it's a little bit more clear, I think. And actually, if I'm doing this, I don't even need that on a new line. So minor formatting aside, this is pretty much what we need in order to get this working. So in order to actually run this, at bare minimum, we need to tell ZoomCharts what unit our timestamps are being given. And thankfully, ZoomCharts tells us what time unit it requested, or time step, so we can just say we're returning the timestamps in the unit it requested. So we can say unit, step, don't forget the comma on the end. And there we go. Now we can just delete the code we had just for sake of illustrating the concept, and we should be able to refresh, and look at that, we see data in the chart. And just to confirm, if I zoom in on November, I can look, okay, we have data at November 12th, we have 87. Here, we have the UTC date, November 12th, 87. And there you go. We can check again at October 20th, for example, We have October 20th, 180 in the chart. So there you go, our data appears to be loaded correctly. And just in case you were confused by that comparison, the date.utc function takes months in zero-based. So month 0 is January, and month 11 is December. So yeah, it's a little bit different than the way we usually write dates, but that's why October is 9 in the date.utc function. We're not quite done with time chart data loading though. And if you remember back to the lesson where we discussed time chart data loading, you might remember the reason why. Time chart needs to know the range of dates that it's representing, because the first date it receives data for isn't necessarily the first date in the range it's representing. All of our data here, for example, might be all the data from the second half of 2023, and it just happens that there was no particular data on, say, July 1st. So it doesn't know that. We need to tell ZoomCharts that. And this is especially important in the case of cross-chart filtering, because even if, let's say this is the correct range, let's say this really is the first date in our range of data, and this really is the last date in the range of data, those dates might get filtered out depending on how, well, whatever filters are in place. And so if that's the case, then ZoomCharts is going to guess the wrong date range when it has only a subset of the full data set. So we're going to go ahead and specify our data limits. So the way I'm going to do this is I'm going to say the first date and last date in the raw data really is the range of time chart, and we just need to make sure we're consistently telling time chart that that is indeed the range of data we're representing. So I'm going to go ahead and create a variable here. I'm going to call it times, and this is, as you might imagine, going to be all of the time values in the raw data. And this is just for convenience because we're going to try to extract the minimum and the maximum. So I'm going to say vals, and this is going to be vals sub, and I'm going to use our data indices date. And there we go. These are going to be our times. So if I go ahead and just do console.log just to show you, if I build and run now, and I haven't done anything ridiculous, you see now we have an array with all of our timestamps, which is exactly what we want. The next thing we want to do is we want to take the minimum and maximum of this. In this case, the data is sorted, but I'm not going to assume that because, our data might not be sorted. Who's to say that's going to always be the case? So I'm just going to create a basic reduction here. So I'm going to say time date start, or time data start rather, is times, I'm going to use the reduce function. So we have an accumulator and our current value, and we're just going to say it's the minimum of the accumulator in X, that's what we're reducing with. So this will just go through every data. It'll take the minimum of whatever the current value is and the data point. It'll do that for all the data, and this will eventually find the minimum, of course. And I'll just say times 0 is the start point. This is going to assume we have more than one time, but that's going to be totally okay, I think. But keep that in mind if you're just copying this for the sake of example. This is assuming there's data, so if you have an empty data set, this would crash. And we're going to do the same sort of thing for time data end. So the max of all the data set. And now if I just log time data start and time data end, I'll just use times for comparison. You see, look at that, it is finding the earliest date, which is correct, and the latest date, which is also correct. One thing that isn't quite correct yet, though, is the value of our time end. Yeah, we found the end of the data, but if you remember from our lesson where we discussed setting up time chart, the data limits are exclusive. That is, if I say the start of the final data point is the data limit end, it'll say, okay, everything beyond the start of the final data point is no longer part of the data range, including, well, the value itself. So it would say this isn't part of the data range, which is wrong because obviously the final data point is beyond the start of the final data point. And that's really just a long-winded way of saying we're going to want to pad the time data end by the size of, well, our data unit. And you might wonder, how are we going to do this? I'm going to keep things very, very simple for this, and I'm just going to say our data size is by default 1 day, and I'll just add the length of 1 day in milliseconds. So 24 hours times 60 minutes an hour times 60 seconds in a minute times 1000 milliseconds, and that's the conversion factor. And with that, we now have our correct time data start and time data end. So at this point, we can just go ahead and add them. I'm going to go ahead and add data limit from is our time data start, and our data limit to is our time data end. And you notice I calculated these outside of the data function, and that's very important. Well, strictly speaking, you could do it correctly inside the data function, but it's trickier because when you're inside the data function, we're eventually going to be using filtered data, and the filter data obviously is not going to have the full data range. So that's why I'm calculating it once with the raw data outside. You could in theory do it with the data. You could in theory do this inside the data function as long as you were careful to access the raw data, but that's asking for some confusion, so I'm just doing it outside. And with that, we now have our data range. So I should be able to refresh, and there you go. There's a couple extra details here, though, while we're at it, though, namely the from and to range. So ZoomCharts can ask for a certain range of data in its data function, and we're just going to do the same thing we did in the time chart data lesson, so I'm not going to discuss this in too much detail here. We'll say if there is a from value, we'll use that. Otherwise, we're going to say our range is from the start to end. So in other words, ZoomCharts might tell us it's looking for a certain range, and it might not. If it is, we'll use that range. If it's not, we'll just say, okay, our range is the full data range. And we could do more here, but since that's not the main focus of the video, I'm just going to use from and to, and just leave it like that. So this is going to be our setup for loading time chart data for the sake of this example. So next, we're going to load the data in pie chart. So this is a little bit tricky because what we're trying to do here is we're trying to get all of the values in a particular category. So we want what's the total value in category A? What's the total value in category B? What's the total value in category C? And since there's more than one data point per category, well, you see, that's not so simple. We can't just look up, oh, C has value 43, because there's also this 29 value that we want totaled in. So we'll actually need to aggregate all these different data values by category in order to get the data we need for pie chart. And that's the main thing we're going to want to watch out for here. So I'm going to go ahead and create data. We're going to use the data function. And this is the first time we're using a data function for pie chart. So the parameters in the case of pie chart is it sends an ID for what slice it's looking for. It gives a limit for the maximum number of slices it wants, and an offset for where does it want to start looking for slices. So this is basically analogous to the from and to in, well, the time chart. It's telling us what range of the pie ID it's looking for. And after that, we're just going to have a success and a fail function, which work just like in time chart. We call success with the finalized data object that we want to send ZoomCharts. And with that done, well, not done, we have the template for it, we're going to go ahead and try getting our data aggregated so we can pass it into the success function. So the way this is going to work is I'm going to create an object to hold all of our aggregated values. I'm just going to call it values. And then I'm going to want to go through the raw data and perform the aggregation. So I'm going to say raw data values for each vals, and there you go. In this case, I'm iterating through the data with a for each function. You could, of course, use a for each loop or a for loop or any other looping construct you want. That's all totally fine. I'm just using this one for sake of example. And with that, now we have our current entry. So right now, vals, this is going to be one of our rows of data, and we're going to want to aggregate, basically, we want to look at the type and want to aggregate the value into the total for that type. So that's a little bit tricky because right now our values starts out empty and it might not have an entry for the type we're interested in. So first of all, let's just extract the type from the data. So this works exactly like we did for time chart. In fact, I'm just going to copy and paste subtype. There we go. So this is our type in the there, and I'll just actually extract the value just the same, because why not? Value, this sub value. And what I want to do is I want to look, do I already have a running total for this type yet? So I'm going to say if values.hasOwnProperty type. Or really more accurately, if not values. So if I don't already have a running total, then I want to create one so that I can aggregate into it. Say values subtype. In this case, I don't have one, so I'm going to create one. And what does our aggregated thing look like? I actually want this to look like the pie chart data format so that it can ultimately just take our final aggregated values and just pass them straight to pie chart. So that means the name is going to be the type, and the value is going to start out at 0. Because, again, if we have nothing yet, we have nothing to aggregate. And once we definitely have an object, then we're actually going to perform the aggregation. So we're going to say values subtype, and this will definitely exist because we just checked and made sure it does. And we're going to look at the value, and we're going to add, well, our value. And really, that's the gist of summarizing our data. So I'm actually going to comment this out because I want to not run into an immediate error. Well, I'm going to get an error anyways, but I want to just log this values object so you can see what it looks like. So values, not value. So if I go ahead and run, you see this is what our aggregated values look like. And you see we have the different types and we have the summed values. So if you look at a very simple one like 43 and 29, 43 plus 29 is indeed 72. So that suggests our aggregation is doing exactly what we expect it to at this point. So now we just need to actually construct the pie chart object. And this is really, for the most part, very simple. I can, much like I did with time chart, to an extent, I can just pass the ID and limit straight into the object because I'm not going to be doing anything with those, so I'll just pass it straight back. We'll say, yeah, sure, this is correct for whatever parameters you provided for us. And we'll just assume that's the case. We're not going to do anything too fancy there. And then we need the sub-values, which is what actually contains the values. And now, since this is a JavaScript object and not an array, which is what ZoomCharts wants, we're going to need to do a basic conversion. So I'm going to say object.keys values. So this will give me an array with all the different types that we've aggregated. And then I'm going to map the key to the values of the key. And just like that, I should now be able to run. And look at that. If I bring this down a bit, there we go. You see, now we have a pie chart with all of the different, well, categories, all aggregated, just like we wanted. One minor detail I'm just going to add in, and I think this is going to be the only minor detail for pie chart, is I'm going to sort the final objects, just so that they're in alphabetical order, no matter what the original order was. So I'm going to do a.name.locale compare to b.name. And there we go. I think that line is just long, so oh well, I can't make that nice and short for you, but that's okay. That should still sort it. And yeah, there you go. And I think with that, unless I'm missing something, we now have all of our data for all the charts loaded. I think this is all the setup we need for that. All right, so we now officially have both of our charts set up, and they both get their data from the same common data source. And that's really the point of all this setup that we just did, that they have the same common data source, because that's a prerequisite to doing cross-chart filtering. If the charts aren't both using the same data source ultimately, even if they need to do some you can't exactly cross-chart filter because you might be filtering a completely different data source. So that is the whole reason we did all this, just to be perfectly clear on that point. But now we have the prerequisites for cross-chart filtering, and I've shown you how you can set up those prerequisites, so if you happen to have a different use case than this, which you very probably do, you now know how a lot of the details of setting that up works, so you can set up whatever your situation is to at least get to the starting point of doing cross-chart filtering. And that's really all we wanted to cover in this video. So now that we have the prerequisites for cross-chart filtering set up, in the next video, we're going to discuss the core module, the core cross-chart filtering behavior. How do you implement that once all the prerequisites are in place? And that will be the topic next time. Until then.